Assalamu alaikum everyone. We are here to present our group assignment for the course Microprocessor. This assignment is supervised by Dr. Afzan bin Othman. We are from group 9 and our group consists of 4 members. Myself, Sadnan Saqib.
I am Mohammad Yusuf.
I am Wahidur Rahman.
And I'm Salman Rahman.
In this particular project, we are required to display our matric card number using 7-segment display and 80 MEGA32 as our microprocessor. As we can see on the left hand side, we have 4 switches. So each switch will represent our matric card number. However, on the right hand side, there are 2 more switches, which is indicating the interrupt function. Whenever we are pressing switch 6, the LEDs will blink. Whenever switch 7 is triggered, the LED will start to run. However, whenever we are pressing switch 0, it shows the matric card number. But in the middle, if we press switch 6 or switch 7, then the LED will start to blink. This shows the priority of the interrupt function. Now, I would like to ask MD Wahidur Rahman to continue with the further presentation.
Thank you, Sadnan. In ATmega32 chip, there are 4 ports, which are port A, port B, port C, and port D. 8 LEDs are connected to port A. 4 switches are connected to port B. Common anode 7-segment display is connected to port C. 2 interrupted switches are connected to port D. The clock frequency of our ATmega32 is 1 MHz. The delay of 7-segment display is 1 second, and the delay of LED is 500 milliseconds. Now, my friend Yusuf will present the demo.
Thank you, MD Wahidur Rahman. In this demo, we'll see what happens when we press the switches. So, first of all, we press SW0, which will show the matric card number of A17KE4015. The second one will show A17KE4009. The third one will show the third one will show A16KE4012. The fourth one is A17KE3010. The interrupt switch SW7, which is connected to int 0. If we press this one, it will show the blinking light. The interrupt switch int 1 will be showing the running light. Now, if we press any of this switch, for example, if we press SW1 and then press SW7, it will pause the process of the 7-segment and will do the interrupt code. After the interrupt code is done, it will go back to the 7-segment normal process, showing the matric card number. So that was the demo. Now my friend Salman Rahman will explain the code.
All right, thank you, Yusuf. So if we see in the at the beginning of the code, we can see that we have fixed the CPU frequency at 1 megahertz, and the following lines are actually the header files that are declared that we will be using, the IO header, the delay, and the interrupt. And then we define the 4 buttons that we will be using for each student. And then if we go for the first function, as we can see that it's used for initializing the ports, the port A, B, C, D. So in this case, we have port A port A and C as our output, while port B and D is our input. And then if we go down, we can see that for each of the characters of the metric card, we have set a character array for each of the metric card numbers. So, and then if we go to the debouncing functions, so debouncing functions are actually used for helping us when for the switch presses. So it manages the delay and the timing for the triggers as well. So if we go down, we can see that this is the main function. So in the main function, the first thing we do is we call the initial port initialization function, and then we initialize the interrupt. So in this interrupt, the interrupt we are using are triggered on falling edges, and the interrupt is then enabled globally. And then the conditions are stated for the switches, for the buttons switches. So for each switch, like which switch upon pressed, what metric card will be shown. And then if we go down, this is basically the main function. And then we end our code with the interrupt service routine. So for the first interrupt, the LED will be blinking 5 times with 500 millisecond delay, while the interrupt 1, we have LED running light. So the first LSB LED will be lit and then goes to the MSB and then comes back to LSB and stops the program, and then continues with the remaining work of the previous interrupted program. So that's all from us. Thank you very much.